We will. Give me a second. Yes. Yeah. Okay. So this is what a piecewise function looks like. You're going to have a function. Please. You're going to have a function, and it's going to be broken off into two different pieces, which is what it's called piecewise. So for some part of the domain, everything x is less than 1, this is my graph. And if x is greater than 1, this would be my graph. So this is the function I'm using if x is bigger than 1, and this is the function I'm using if x is less than 1. Is that okay? Make sense? So the very first thing we're going to do is we're going to evaluate the function at different intervals, or at different pieces. So the first thing I'm going to do is, what is my function if x is 0? Well, we have to determine which equation we use. If x is 0, does it fit the top equation, or the top domain, or does it fit the bottom domain? Well, let's look. This one is all of my values less than 2. This is all of my values greater than 2, so it fits the top equation, right? So we take the x squared minus 1. Sorry, we take the x squared minus 1, and everywhere there's an x, what do? Plug in a 0. Why? Because I'm saying x equals 0. So I plug in a 0, and what do we get? So I'm going to say probably the best way to say it, although there's not a lot of room. F of 0 equals negative 1. Yes. We're not there yet. Now, what part of the domain is 2? Is it the top equation or is it the bottom equation? Raise your hand if you know. Raise your hand if you know. Top or bottom? Raise your hand if you know. Is x equal to the top domain or the bottom domain? Lindsay. The top. Why? Yeah, because of the or equals to. Lindsay gets 2 points. If you do that, you also get 1. So because of the or equals to, I'm going to take this and I'm plugging it into the top equation. So f of 2 would equal what? 2 squared minus 1 is 3. Any questions with that? Does that make sense? How you decide what goes where? What about x equals 4? Which function would you use there? The bottom, because this is all of the values greater than 2. So 4 times 4 plus 1 of 4 would equal what? 17. All right, on your own, will you please try part B? The second question, A, B, C, D. This time I have 3 different pieces of the domain, right? See if you can figure it out. You may not need them. I'm just hoping that the graphing is easier if you have the book. If it's not brilliant, fine. Okay, f of negative 4, is that the first, the second, or the third part of the domain? The first, right? So these are all values between negative 5 and negative 1. So you plug in the negative 4, and you get domains will ever overlap? No. You want to know why? No? Well, I'll tell you anyway. Because if they did overlap, then it wouldn't be a function. Because you would have one equation coming like this, and the other equation coming like that, and it wouldn't pass the vertical line test. So they have to have, like, looking at these graphs down here, there's never going to be an overlap. Because if it did, it wouldn't be a function. Does that make sense? Like horizontal? Oh, yeah. But notice how this one has an open dot, this one has a closed dot? Yeah. So technically, at 1, I need to move the function because of the open dot. And on B, at 1? -2. It would be hard to calculate. This has a closed dot, that's pretty obvious. This has a closed dot, that's pretty obvious. Let's pretend like the red dot was open.
Well, how do you know?
You don't, I just told you.
There's a dot.
Now there's a red dot, now we all know. Okay, moving on. Brandon, it was a typo on my part. Keep going. Okay, so SM3 is the middle equation. We plug in 3 minus 1. It's what? 2. And then what about F? It is on the last one. We times it by 2. It's 36. Hey, have you already found a part in your homework that deals with this stuff? If not, do it. How many problems are there? 1 set of equations, 4 to plug in. Okay, you guys have 2 minutes. Go. I mean, don't know because that's still in the race. We did.
I know, I heard.
I grade your test.
Hey, listen. Sometimes I rush and slip up. Last time I got checked out, so I didn't even have time to double check. I came in the morning, I was falling asleep, I was finishing. But they capital E.
I haven't done one. You guys like, well, you can figure your air like that. They're probably, I still have my eyes in behind that. All right, any of your 2 minutes are over. There now. 2 minutes for my family means just an extended period of time. There's not an actual, like, timer. All right, so now we have to take these equations and write the function itself. Is there a part of your homework that you have to do that? No? Yes? No? No, but we're going to do it anyway. It's worth our time. So the first thing it's going to look like, it will help us graph. This is what the Post-it notes were, although you don't have to really use it yet. Completely ignoring the blue. What's the equation of this graph? First of all, which one of those sticks does it follow? Is it a square? Guys, I realize the money. Okay. Is it a square? Is it a cube? Is it a square root, a cube root, a line, or an absolute value? This one right here. It looks like a line, right? I'm not going to call it an absolute value unless I see it turn around. Okay? So I'm going to say that that's a line. Now, how do you write? Well, okay. Everybody equals. Ignore this for a minute. What values of x does this line cover? So x is less than or equal to. Is it or equal to though? No. That open dot right there means that it's not or equal to, so less than 1. Right? Now how do you write the equation of that line? Here, I'll do it in red. So you're going to have a slope, and then you're going to have an intercept. You have to fill in those 2 pieces. What's the y-intercept? Okay, raise your hand if you know. Does it go in the first spot or the second spot if it's the y-intercept? Haley? Good. Haley gets 2 points, everybody else gets 1. Now the slope goes in the first one. So from the y-intercept, I went up 1 over 1. What's the slope? 1. Do you have to put the 1 there? No, but it's not wrong if you do. Like that. Okay, now let's look at the blue line. Which of these graphs does the blue line follow? It's clearly not linear, right? So the pattern for a squared would be over 1, up 1, over 2, up 4. Did it follow that pattern? Yes, so it's going to be an x squared. It's moved to the right 1 unit, right? So what's going to go inside of here? So it'll be a plus 1 or a minus 1? This one? Yeah, minus 1. Good. Now, if y'all know that, I can't get points. So just do that to give yourself points. If you knew this, you can get a point as well, just for these methods. Now, what part of the domain does this follow? X is plus. It's from here on to the arrow. So x is greater than or equal to 10. Done. Now in part B, it's broken up into 3 pieces, right? Sorry, backtrack questions? So you didn't get that? Okay, let's like 0 of it, or like okay, well then I'm going to play on a little bit more. Do me a favor, guys, be quiet. Okay, so this one is broken up into 3 pieces, right? Is that okay? You've got the red piece, the blue piece, and the green piece. Is that okay? Now, unfortunately, yours don't. Okay. We added that little dot in, so we don't have to worry about if it's open or closed. Now, this first line, what's the domain that we're using for the red? It has to be bigger than -5, right? But less than -2. So how do I write that? X is bigger than or equal to -5, but less than -2. Questions with that?
Which one are we talking about again?
Part B, the red.
Oh, I think it's not there.
Yeah, it's right. Yeah, and then that one was open and decided. Is that okay, Dylan? Then what? How do I write a function that is flat? Where does it? If you were to extend this, where would it cross? Hold on. If you were to extend that, where would it cross the y-axis? It would be 0, right? Not x equals 0, which is why I have this analogy. Quiet, please. Guys, I know you're working on your homework, but you have to do it silently or not at all. What's the slope of this line? 0, right? So it doesn't go up or down. The red line is y equals 0. That's how you would write that one. Or I would just have to put 0, actually. Just 0. Because the y equals is right here. Is that okay? This is the same as saying y equals.
But the full way is equal to 0.
Inside of here?
Yeah.
No, it's just ugly. So we get rid of it. Oh, okay, now let's look at the blue equation. Is this a line or a parabola? Parabola. Now, what's the domain from where to where? This, assuming, is the closed stop. So from -2 to where? It stops at 1. So with your Post-it notes, if it's helpful, I wish I had giant Post-it notes. If it's helpful, you can close off only everything except for the blue. And just look at that equation. I don't know if it's helpful yet. I think it's going to be more helpful when we come to drawing them ourselves. So, how do I write the equation in the line? Where's the vertex? So, 0, 4. So this would be x squared plus 4. Is that okay? Is that 0, 4? And then what's the stretch? From the vertex, I went over 1, down on 1, so what does A equal? Negative 1? So I'm going to put a negative right here. Yes. Oh, but I never put the 1 right here. Okay. Thank you. Now there is a break in the graph right here. That's okay. There's no overlapping. That's the biggest thing, is not to have it overlapping. Now let's look at the green graph. I don't have a good green marker, so we will use blue instead. So what's the domain for the green graph? From where to where? The green graph goes from 2. I didn't put our equals to, right? And then when does it stop? 5. Okay, that's the domain of this one. This is a line, right? Now kind of imagine that it keeps coming up like this. What would the y-intercept be? Good. So y equals something x plus 3. Now we need the slope. The slope is going down 1 over 1, down 1 over 1. So what's the slope here? Negative. And that would be the equation of those graphs. Any questions with those? You don't have to do them on your own, but I'm hoping that doing it this way, now when it comes time to graphing, it'll be a little bit easier. I could be completely wrong, but in any case, that was fun. Let's keep going. Did you get that on your notes? Because if you didn't, I'm going to have a notebook check and because you're not paying attention. All right. Ignore these steps. This is why I gave you a post-it note. Move on to number 3. The first equation has to do with everything less than 2. So what I want to do is take my post-it, if this helps you, and completely cover up everything more than 2. Is that okay? So cover up the part of the domain that you don't care about. Sometimes you'll have to cover up 2 parts of the domain, right? Which is why you have 2 post-it notes. Would you ever have to cover up 3 parts of the domain? No. Now, this is tricky, I can't hold it up. Now, what does an x squared plus 1 look like? So, where's the vertex? At 0, 1, right? So there's nothing inside there, it's been moved up 1. So my vertex is right here. Now, looking at the x squared graph, what's the pattern? From the vertex, I go over 1 up, 1, over 2 up, 4. So, okay, from the vertex, over 1 up 1 on both sides. Go back to the vertex, over 2 up, 4. Now, it is possible in your old classes, and when you learned it last year, that you learned the 135. I teach the 149, because when you start looking at all the other ones, the patterns themselves. You can do whatever you want. Now, I hit the post-it note on the one side, right? Can I keep going on the left? Yeah. So over 3 up 9, I believe it's a 10 by 10 grade, so that's easy. Now, right here on the far right, I put a solid dot. Should it have been a solid dot? Why? Because this indicates it needs to be open, like that. And then, the other thing you need to make sure you do is that it's not, there's no barrier on the left, right? So you have to put arrow. If you don't put arrow, it's not getting done. So that's the first part of the graph. Yes. Because of there's no origins to it. Any other questions? The open circle happens because it's just less than, not less than or equal to. Anything else? Okay, now we're going to take our post-it note and cover up the other side, what you just did, because now we're talking about the domain for everything greater than 2. And we will stop at the post-it note, and when we take it off, and then a bunch of greater happens. How do you graph the square root of x? Where's the starting spot on the square root of x? Now, this one's a little bit harder because the starting spot is at the origin, right? And then you just cover the origin. So maybe like somehow remember this. So you may want to, I don't know, the starting spot would be here, right? I'm not going to graph it. And then it would be up 1 over 1, and then it would be up 2 over how many? 4. 4, which is right here, so maybe this one really got problem, 3 over 9, kind of like this. And we would stop something like that. So what's that? Yes. Why do we start that one? That's terrible. Terrible problem. Do another one.
I believe your homework is a little bit easier than that one. Let's do another one. Part B.
The first thing I want to look at, I'm not going to home paper anymore because it's awkward, is the domain. So if you're using the post-it note, is that helpful, by the way, post-it? If you're using the post-it note, you're going to cover everything below 0 and above 8, right? Because we're only revealing the part of the domain that we really need. Below the 0, above the 8. Now this is, the first graph is a cube root, which is over there. Where's the starting spot of the cube root? Starting point is at 0, 0. Do I put an open dot here at 0, 0 or a closed dot? Because of this, I put a closed dot, right? And the pattern. The reason, if you weren't here last time, or you were over here perhaps, the reason this is the pattern is if I were to take the cube root of 1, I get 1, right? And if I were to take the cube root of 8, what do I get? 2. That's why the pattern is what it is. Likewise, if I take the square root of 4, I get 2. So if I were to continue this pattern, it would be up 3 over 9, or up 3 over 3 cubed is 27 this way. Over 2 or 3. They're kind of reversing. Okay. So the pattern is up 1 over 1, right? Up 2 over 8. And at the 8, should I do an open dot or a closed dot? Open. On the text, if it's not obvious and you make the mistake and close it up, it is okay to go like this. So I know. And then, like that. Now the next part of my domain is from 8 to 10, right? Just this little piece right here. Again, you're covering up part of your graph, so it's a little bit tricky. If it's an absolute value equation, it starts with the origin, right? And because it's negative, what do you think happens to the absolute value equation? It splits down. Good. So, I'm going to use another card. Imagine it starts here, and the slope is still 1, right? So, down, down. We're not drawing yet. When do we start drawing? At 8. Closed dot or open dot? Closed, and then down, down. Do we need an arrow? You need an arrow on this one? No, why? Because it closes at 10. In fact, we need an open dot there, right?
That's weird. Is it better than you remember it or worse? Better? You don't remember. Okay, let's try part C.
The first graph is from -6 to negative or +2. So if using the post-it note helps you, get a post-it note on. -6 when we start searching. This is a square root graph. We need to know the starting spot of that graph. Where is the starting spot? -4 zeros. So this is where my graph starts, right? Now, it is helpful to know what the basic shape of each of these graphs are. The x-squared graph looks like this, right? The x-cubed graph looks like this. What does the x-squared graph look like? Right? Like that. So there's nothing going on here, right? And then what about the x cubed? It looks like that. forever in both directions. So if I have a starting spot of this, and I use my pattern, up 1 over 1 is all the way to, up 2 over 4, up 3 over, and stop. So it's going to look something like this, with an open dot there, ish. Even though the domain says I can go all the way to -6, does my graph on this one go all the way to -6? No. Is there anything wrong with that? No. Weird. Okay. And then what about this 6? How do you graph something that says y equals 6? From 2 until 8, it's just a line, but it's a flat line. Right? Who's correcting me? Everywhere, I know what you're doing. Like, if you don't want to pay attention, like, put it back. It's way back. Right. From 2 until 8, everywhere there's an X, it doesn't matter. My graph 3, 4, 5, 6. Everywhere there's an X, close dot. Open dot. That's what it would look like.
It's a flat line because there's no slope, right? Have a good lunch. It's good timing. See, they like me so much, the bell rings and they all stay. Have a good lunch. And welcome back. Battery's not going to die. I think we're okay. Oh my gosh, it's so hot. I am not finishing that sandwich. Dang it, it was expensive. Okay, part D. Okay, part D. Do you guys want to try it? See if you can do it? No? If we move on to the negative page though, am I still in Piecewise? No, this is my last Piecewise example. Yeah, let's do it together and then you can work on your homework for a minute. Okay. Whew. So, where is the domain changing on this one? The graph changes at what domain? Here. It's changing at -2, right? Okay, so that's kind of the big piece. The first one, how do I graph an x squared plus 4? Again, so I don't know why these notes are messed up. Backtrack, I'm sorry. On your homework, like so on this one, when I'm graphing it, really it starts right here, right? Plus 4, and then it goes down and does weird things. On your homework, the starting spot is more aligned. I don't know, this is different. Yeah, it's not going to be as hard as this. Oh, hold on, somebody yell you're late when she comes in.
You're late!
I know! Okay, so, on the x squared graph, the other thing you can do if you don't like the whole post-it note idea is that, I mean, you can draw the whole thing, right? If it were allowed in this domain, it would cross right here, right? And then it's a negative, so rather than going over 1 up 1, you're going to go over 1, down 1 on both sides, right? And over 2 down 4, and over 3 down, what, 9? And the graph would look something like this, right? And then if you wanted to, you would just have to erase part of the domain that we don't care about. When do we start caring? Yeah, about right there. Is this an open dot or a closed dot? Open dot. And then something like that. It should look kind of curved-ish. But it is only just like that tail end where it's almost straight anyway. So that's everything less than -2. So if you wanted to draw the entire thing and erase the part that you don't need, you could. Questions with that part? Okay, so let's try the other one then. This is an absolute value equation. What does the absolute value equation look like?
Like
A V. Good. Dylan, give yourself 2 points. Everybody else in that can have 1. Except for if you're working on your homework right now, because then you're not actually part of the notes conversation. Get that point back up. Okay, so it's the V, right? The transformations with the absolute value equation are the same. So because of this plus 4, I still start up here at plus 4. The slope, A, right here, is 1, so I still use the up 1 over 1. And the more points you put on your graph, the more accurate your graph is, the happier I am. And then I would stop there. If you were using the Post-it note, you would cover up the blue part of the graph, which yours may not be blue. This right here is a closed dot. And yeah. So they look kind of funny. So I'm going to pause my recording for a minute. Jessica, it's your job to make sure I unpause it. So let's try number 5 together. I need to find it. Hold on. And then we have to move on. Yeah, number 5 looks really weird. Okay, pay attention, please. So on number 5, there's 2 parts of the domain, and it changes at -2, right? So I don't have a Post-it note, so I'm just going to draw a little line right there. Is that okay? So before -2, I'm talking about an x cubed graph, right? So we're doing number 5. It's 0.5 x plus 4 cubed. How do I use this to determine the starting spot? Left 4 and then up and down nothing, right? So left 4, my starting spot's here. Now we're going to look at the general pattern for a cube graph, which is over 1, up 1, over 2, up 8. And we're going to take all of our ups and multiply it by the stretch, or the compression. In this case, we're going to multiply it by 0.5. So I'm going to half it. So to find my next point, rather than going over 1, up 1, I'm going to go over 1, up half on both sides. And rather than going over 2, up 8, I'm going to go over 2, up 4. Now this is on that change line, right? So it's either going to be an open dot or a closed dot. Is this an open dot or a closed dot on the right? Closed. Good. So over 2, up, not 8, now it's 4. Closed dot. And then on the left, over 2, down 4, because that's the general shape of a cube. And then you connect them. Something like that. I put an arrow down here because it goes on forever, but I don't on this one because it stopped. Now let's look at the second part of the equation, which looks like this. Where's the starting spot of this absolute value? Has it transformed left and right or up and down? No, it just stays at 0, 0. So my starting spot here is at 0, 0. Now we haven't done one of these yet. What's the slope of the absolute value? Yeah. Instead of going over 1, up 1, we're going to go over 1, up 2 because the slope is 2. And because it's a line, right? I don't have to do anything weird, just kind of up 2 on both ends. It remains constant. Now this is one of those that one graph stops and the other one starts in the same spot. So the blue one technically has a closed dot. The purple one technically has an open dot. But when you put them together, are you going to see the difference? No, it should just be one big old dot, right? It's okay if you do it that way. So that's what this graph will look like. Kind of weird, yes.
So you know how like it has like the 0.5 or whatever?
Mm-hmm.
So you always gonna like you never multiply with the 1, 2, 3.
No, always the ups, never the overs. Yeah, because the up or the overs are your input value. Like you're inputting 1 in for x, 1 in for like if you were evaluating, making a chart. You can choose these, and they can be right in a row, you know, and then these could be jumping around doing weird things. That's why we multiply that otherwise. All right, let's go back to the notes. How many piecewise functions do you guys have to do? About 5 too many? You guys have 6 total? Number 7 I got looks almost like a line, but not quite. All right, go back to the notes. Next page. Now let's talk about the step function. The step function is a special case of the piecewise function, and this is what it would look like. So between 0 and 1, my graph is at 1. And now we have a closed dot on this end and an open dot on this end, right? Which is hard to see when, let me zoom in. I mean, it's hard to see. And then it bounces up to 2. Between 1 and 2, it's at 2. And then open dot right here. And then between 2 and 3, it's at 3. And then open dot right here. And then between 3 and 4, it's at 4 with an open dot right here. And if I were to continue going, this is what the step function would look like. has open dots because at the one point it jumps from this line up to here. So if you were parking in a parking garage, what usually happens? For the first hour, like, this isn't an example of that, but maybe this would be an example of like babysitting. So these are like $5 an hour. I don't know, how much do babysitters get paid?
Not much.
Maybe no, 5-ish an hour?
I got
Well,
Not worth it?
not much.
I babysit.
It's not much, especially here in Utah. I'm just gonna say that.
Okay.
Pretty like every few days.
Calling you. I actually can't call you.
No, I mean like specific.
Okay, so pretend like this is a babysitting gig. So you work for about an hour, right? For the first hour, you get paid $5. And then once parents are gone, anywhere between hour 1 and hour 2, the rate jumps up to $10, right? And anywhere between hour 3 or 2 and 3, the rate jumps up to $15 for the entire thing. That would be an example, guys. Ooh, that's like a lot of stuff ever so I can yell at you people. That would be an example of where you would use the step function. A parking garage would be kind of the same thing. So in a parking garage, usually, like the first 30 minutes are free, right? So this is what it would look like. So that means for every 30 minutes. So for the first 30 minutes, you would pay nothing, right? And then what happens for the next 30 minutes? And then it's going to jump up to some sort of fee. And then for the next hour, maybe it's like this, and then the next hour, and then the next hour, and so on. So that's where step functions are used. Does that sort of make sense? Because it's not a gradual increase, right? Okay, let me zoom back up. And I think that's what this paragraph says. So we're not going to read it. So there's several different kinds of step functions. We're focusing on one of them, and it's called the greatest integer function, or the floor function. There's two kinds. There's the floor function, and then there's the ceiling function. One of the functions rounds down, and the other function rounds up.
Math 4, math up ceiling, yeah, I see programs.
Brandon, you can't, okay? One function rounds down, the other function rounds up. The floor function, do you think it's going to round up or down? Raise your hand if you have a guess. Do you think the floor function will round up or round down? Let me give you the other choice. The other one's called the ceiling function, the floor function. Okay, base. Probably round down. Base, you can have 2 points. If you would guess down as well, give yourself 2. So that means if I input a 7.2, the symbol for this kind of looks like the absolute value, but with a little like line underneath. I don't know what it's called. But if I gave you 7.2 as an input, and I was using the floor function, I would round that to a 7 because it's rounding down. So if babysitter, now do we want this as a babysitter? Do we want to use the floor function or the ceiling function? We want the ceiling function, right? We want them to round up. So, yeah. Or, guys, either like get to the back of my room and talk quietly or pay attention. Negative 2.2, that would round down to the negative 3 because it's the next integer below it, right? Yeah. Is that okay? Because integers, like, that's different. Just like the notation has the extra lines below, we always take the input values down to the nearest integer. So what does that look like on the graph? Let's just do an XY chart really quick. And normally I pick pretty numbers to go in here, but this time I'm not. Let's pick negative 2.3, negative 1.9, 0.7, 1.6, 2.3. I missed a few in there. We're going to have some gaps, but that's okay. We'll see if we can figure out a pattern. Let's call this negative 0.7, and then we'll throw in a 0.4. There, now we're not going to have gaps. Okay, those are our inputs. They're a lot uglier than normal, but hopefully that will give us like where the graph's going here. If I'm inputting a negative 2.3 into my floor function, what would the output be? If this was the input right here. These, by the way, don't have the right notation. They should have little, like, whatever these are underneath. I don't know why. So what's the next integer below negative 2.3? Wouldn't it be negative 3? It's the next integer below it, if you're doing a number line. Okay, if I were to input negative 1.9, which is about here, what's the next integer right below it? It's negative 2. And if I were to input negative 0.7, the next integer below it would be negative 1, At 0.4, it would be 0. At 1.6, the next integer below it would be 1, and so on, right? And then 2, and so on. How would I graph this? That means everything between, the easiest way to start it is right here. Everything between 0 and 1 will be here at 0, right? Because if I plug in 0.5, it's still going to be at 0. If I plug in 0.9, it's still going to be 0. If I plug in 0.9999, it's still at 0. Until you get to the 1. At the 1, what happens? It jumps up to the next integer, right? So it's really kind of ugly. You have a little open dot right here. And then you jump up to the next integer. 1.1, 1.2, 1.3, 1.4, 1.99999. And when it gets to 2, what happens? It jumps up to the next integer, right? So open dot here. Because at 2, it's no longer at the 1. It jumps up to here. 2.1, 2.2, 2.3, and what happens at 3? It jumps to 4.
Are we using math.4 or math.5? How do you know?
Jumps to 5. This, I don't know why the notation, I must have screwed up. It should have the little like underline right there. So those are 4 functions. No, I just said it's easiest to start here and then do it the other direction.
It's not like an absolute value.
Nope. Okay, yes. The homework does, we're good there. Okay. The notes do? It's just not showing up on my, well, look at that. So that's what it would look like. So this is the parent step function, the parent for function. So what would happen, do you suppose, with the -2 inside there with the x? Do you think it's going to go up, down, left, or right? Using the same kind of rules as we did yesterday. It's going to go right 2. So imagine this floor function, and then what are we going to do with it? Move it to the right 2. So I like starting with a 0 and then just shift it. And then from there, the pattern kind of continues.
I couldn't tell if we were.
So you take this function right here, and we just shifted it to because of this. Now question, is this the same thing as this? Do you suppose? Well, look at it. Like, how would you graph this? Wouldn't it shift it down?
Yeah.
Doesn't it look like this shifted down too? Are these equivalent? In this case, I would say yes. What is that? Yeah.
Whoa. So did you just go below the next page? Slow down.
So then we would like shift it this way and shift it this way, so then it would kind of look like. Because it shifted and shifted, and it would look like the X and this. Good. Let's try another one. Actually, on your own, try this first one. Are there even A, B's, and C's on these? No? Crazy. On your next, try the next one, top left. So this one is going to be shifted up, down, left, or right? Up to, right? Up to.
This is one thing that I
Now, if you're ever not sure, you can make a table. It doesn't have to be weird numbers. -1 plus 2 is +1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So the function will look like this. At 0, you're at 2. And every little decimal in between until you get to 1. And at 1, it jumps to 3. And then like this. And then it goes the other side too. I just always like to do the positives first because they make more sense to me. And then just go in the negative direction as well, following the same pattern. We're almost out of time, I'm sorry. But you've already had homework time today, right? A little bit? Okay. What about the next, oh, sorry. Any questions with that? How we shifted everything? How is the next one different? That 3. So really to see what's going on here, it might be easier to do an XY chart. Now let me give you a hint. This problem and the problem below it, depending where the 3 is, so this one's on the outside, this one's inside, right? One of two things could happen. Either it's going to look like this, where we jump 3, but it's still just one long. Either that will happen, or it will make it twice as long before it jumps up to the next one. So one of those two things is going to happen. And honestly, I don't remember which rule is what, so let's just plug in the XY chart to see. I mean, I've done the answer key, like I've known at one point, but I don't remember which one does what. I have an idea, but let's plug in 0. 1, 2, 3. And see what happens. If I plug in a 0, 3 times 0 is 0, right? If I plug in a 1, 3 times 1 is 3. So is this one the one where we jump up higher, or is it the longer one, do you think? We're going to jump up higher. So 2 times 3 would be 6, 9. So this is what it would look like. Between 0 and 1, where am I at? 0. And then I jump up. So at 1, I'm at 3. At 2, I'm at 6. So I jump up to here. And then I jump up to here. So that's the positive way. On the negative direction, you just keep going down. Down, down, down. Questions with that? It's not the funnest stuff we've ever done. It's not my favorite. So then let's try f of x. So x, y, 0, 1, 2, 3, 4. Let's see what happens here. If I plug in 0, 2 times 0 is 0. 1 times 2. Hold on 1 second. So which one? Give me a second. Where's my answer key? Which one's twice as long? Oh, I lied. Okay, so 2 times 4. This one also, I lied. I'm sorry. I told you I didn't remember. Guys. So this one, does this one also jump taller? Yeah. So nothing weird happens with this one. I misspoke. Guys, let's look at this one, however. 0.5. Ignore this plus 1. What would this one look like? Do the XY chart. Let's do 0, 1, 2, 3, 4. If I plug in a 0, the next integer down from 0 is 0, right? And 0 times, is that going to work? Hold on. Hold on. Where's my answer key? Put the little line right here. I clearly want to show you something. I just don't have the right example. Is this the last page in your notes? Okay. Which is why I'm trying to show you something. I just can't find the right problem. Okay, pretend like the step function is over the entire thing. Are we fair now? Okay, 0 times 0.5 is 0, right? And the next integer down from 0 is 0. Nothing weird there. 0.5 times 1 is what? 0.5. And what's the next integer down from 0.5? Still 0. 0.5 times 2 is 1, which is an integer. 0.5 times 3 is what? 1.5, but what's the next integer down from 1.5? Still 1. Do you see what's happening here? So if I plug in the 4, half of 4 is 2. Half of 5 is 2.5, but the next integer down from 2.5 is still 2. So these ones, when this number, 2 rules. When this number is inside the step function, it has to be inside or it doesn't matter, and a decimal, then you're going to have them spread longer. Is that okay? So this is what it would look like. From at 0, I'm at 0, and at 1, I'm at 0. And then it jumps up. At 2, I'm at 1, and at 3, I'm at 1. And then it jumps up. And they're too long. I believe there's one on your homework that looks like that.
Yeah, it does.
Whew, now I remember the rules. We're good. Told you I never taught this before. All right, that's all. Thanks for watching. Peace out.
The test, can you make it really obvious?